NASA's Voyager probe made history by becoming the second man-made spacecraft to formally leave the solar system and travel beyond. The second Voyager probe, named Voyager 2, was launched on August 20, 1977, 16 days before its identical twin Voyager 1 left the solar system via the northern hemisphere. Voyager 2 is the only spacecraft to have made close approaches to Uranus and Neptune as it was launched on a longer mission. After that, it headed for the southern hemisphere of the heliosphere. Now billions of miles from home in the blackness of space, NASA's Voyager has reached a milestone in exploration and is shedding light on some of our solar system's greatest mysteries. What natural phenomena has Voyager discovered? In 1977, NASA's Voyager 2 probe was launched on a Titan III Centaur rocket from Cape Canaveral, Florida, beginning a grand tour of the solar system that would take it to travel to the Jupiter and Saturn systems, as well as becoming the first spacecraft to reach the ice giants Uranus and Neptune and their moons. The Voyager mission, which consisted of 2 probes, was created to take advantage of an alignment that occurred once every 176 years in the 1970s, which allowed the use of gravity assists between planets throughout the solar system. Voyager 1 is currently the farthest man-made object from Earth, located some 14.5 billion miles away. However, Voyager 2 is probably most recognizable due to its amazing multi-decade journey through the massive planets. The Voyager 1 and Voyager 2 probes made important discoveries in planetary exploration, demonstrating that it was possible to explore the outer solar system with just a few spacecraft. They captured exceptional images that remain essential for planetary scientists. On Jupiter, they discovered that the Great Red Spot is a storm the size of Earth, that it has faint rings, and that its moon Io has volcanoes. They also studied the rings of Saturn, the moon Titan with an atmosphere similar to Earth's, and the moon Enceladus, which was geologically active. Voyager 2 then visited Uranus and Neptune, revealing Uranus's dark rings, its skewed magnetic field, and the geologically active moon Miranda. On Neptune, they discovered more moons and rings than previously thought and explored Triton, a captured Kuiper Belt moon that is also geologically active. Voyagers continued to provide new information about the outer planets as they continued on their brave path. In the early 2000s, the Voyager probes were expected to cross the heliopause, the border between the heliosphere and interstellar space. However, because they were designed to study Jupiter's magnetosphere rather than the interstellar medium, the exciting potential was reduced. In 2007, Voyager 2 went through the termination shock and found that the solar system was accelerating through this medium. It was surprising that Voyager 2 was descending below the ecliptic plane before Voyager 1. Although Voyager 1 exceeded expectations, its insights were limited due to instrument failures. However, Voyager 2's plasma instrument was in good shape and provided a clearer view of the heliopause in 2018. These probes have made it possible to study important features on the periphery of the solar system for the first time. Scientists were able to observe that the plasma around an object slows down, heats up, and becomes denser near the heliopause. The interstellar medium on the opposite side of the border is hotter than expected, but the average temperature around the Voyager probes remains low due to the thinness and diffusion of the plasma. The heliopause is a permeable barrier, and seepage was observed in both directions. Voyager 1 found filaments of interstellar particles that had passed through the heliopause before it did, while Voyager 2 observed a thin stream of low-energy particles beyond the heliopause. Voyager 1 experienced the slowdown in the solar wind as it approached the heliopause, while Voyager 2 observed a completely different layer of solar wind before crossing the border. Both probes recorded similar plasma densities, and the sun bubble boundary was surprisingly similar for both. Voyager 1 and Voyager 2 left the solar system at different locations but roughly the same distance apart, which has caused some confusion among scientists. Voyager 2 made discoveries that contradict the idea of a clear frontier. The measured magnetic fields inside and outside the bubble were similar in direction, raising unanswered questions. Voyager 2 found a simpler, thinner heliopause than Voyager 1, with less energetic particles. These findings indicate that the Sun's influence extends beyond its area. Coronal mass ejections and supernovae affect the interstellar medium and can influence the formation of solar systems and the evolution of life. The Voyager data supports this hypothesis and gives us information about other star systems. However, crossing the bubble with just 2 data points is insufficient, and a more complete understanding of the heliosphere is needed to solve these mysteries. We do not know the shape of the trail of the heliosphere due to lack of data. The shape of the heliosphere can be spherical or have a comet-like tail or crescent shape. Other spacecraft leading the solar system will not be able to collect high-speed heliopause data. A 50-year interstellar mission is proposed to study the outermost regions before venturing into uncharted space beyond the solar wind. Voyagers use radioisotope thermoelectric generators for power, which lose power at a predictable rate. NASA has looked at ways to extend the life of Voyager's instruments, including turning off the heaters and implementing energy-saving methods. The Voyager team is implementing power-saving tactics to extend the science mission of the probes. Although this makes them more vulnerable, the probability of problems appears to be low. Voyager 1 could soon use a similar power management system. According to Suzanne Dodd, Voyager's project manager, every piece of data collected in interstellar space is important to the probe's mission of discovery. Although the probes show signs of aging and have run into technical problems, the team hopes to prolong their operation. NASA missions often extend beyond what was planned, such as the Opportunity rover to Mars and the Cassini mission to Saturn. The goal is for Voyagers to reach 50 years of age and reach 200 astronomical units by 2035. Sacrificing individual scientific tools, plasma wave scanners and magnetometers are the last to go out due to their low power consumption. By turning off the most power-hungry instruments, the life of the spacecraft would be extended by a year. Although interstellar space seems empty, there are still solar particles and magnetic fields to investigate. Having two Voyager probes provides a binocular view of space. Until now, the rotation of the Sun's magnetic field in the direction of the interstellar medium has not been observed, indicating the need to update the models. Voyagers have studied interstellar matter and detected radiation from a gamma-ray burst in another galaxy. Its measurements will be compared with those of the IMAP probe, which will be launched in 2025 to map the heliosphere from a closer position. Voyagers will also continue to take useful measurements near Earth. Although its mission is not over, its legacy is strong, including the success of New Horizons and its passage through Pluto in 2015. The New Horizons spacecraft, currently 55 astronomical units from Earth, is exploring the edge of the heliosphere with better sensors than Voyager's. It has captured images of objects unknown at the time of Voyager's launch, such as Pluto's moons and the Kuiper Belt object Arrokoth. Inspired by the success of Voyager, NASA is developing concepts for next-generation spacecraft that could explore the interstellar environment faster and farther. Although Voyagers will continue to break records for years to come, they will eventually stop communicating with us. However, the cultural content selected by Carl Sagan on Voyager's golden records may be discovered by aliens or future humans in space, leaving a memory of our civilization. Although our sun will scorch the Earth in the far future, the Voyager disks will continue to exist in some isolated area of the galaxy, preserving the memory of our civilization.